Okay, welcome to Lab 3 Road Ripper, and today Jacob Bogdan, Paisley Crespo, and Laura Miller will be presenting. So the procedure of our lab was Rex Cars, our CEO, has noticed that the words computer controlled have great marketing appeal. All of our other automotive companies are advertising the computer circuitry they use, and they sell more cars than us. To help increase sales of our cars, he decided that the brake lights and turn signals must be controlled with digital logic. Our chief designer, Chevy Hader, started the design. It used a programmable logic device in order to decrease manufacturing costs and increase reliability. But Chrysler offered him more money, so he left before it was completed. He was working on the design and completed the truth table. As one of the top digital designers, he has decided for us to finish the project. So our first purpose was to design and implement a circuit consisting of 4 inputs and 4 outputs, to successfully derive a Boolean equation from a truth table using Boolean algebra and K-maps, 3. Implement the simplified equation using a digital simulation program using gates, and 4. Implement the simplified equation using a digital simulation program and a programmable logic device. So this is the truth table that we were given, and it basically explains what each light should do. When the brake is used, that is when the stop input is shown. And when the switch is activated, outputs are only for front and rear lights on the car. And then blink is when the clock inputs are used to be generated. Next. And so we were asked to create 4 K-maps for each of the lights. So this is for our right back light, our right front light, our left front light, and our left back light.
Alright, so here we have our Boolean equations, and the equation for our left front is that it's on when the clock and the left switch are on. For our left back equation, we have either the clock and the left are both on at the same time, the right switch and the stop switch are on at the same time, or the stop switch is on and the left switch are not at the same time. And for the right front equation, the clock and the right switch are on. And last of all, for the right back switch, either the clock and the right switch are on, or the left switch and the stop switch are on, or the stop switch is on and the right switch is not on.
Alright, and this is the Road Ripper circuit. It was created using 6 AND gates, 2 OR gates, and 2 NOT gates. We combined the left and right equations, the Boolean equations, to simplify the circuit. And this will output the exact same thing as the truth table presents. This is the Road Ripper circuit ROM, and we were able to create this ROM by taking the 4 outputs and converting them to a hex value, and then each of these hex values were put into the ROM in order so that they can output the correct values. This will give us the same values as the circuit shown before, and that's all we have for today. We were Group 8 and this was Lab 3. Thanks for watching.